So detection of Ssb means recover M of t from the Ssb. So we can recover M of t from the Ssb, so by using spectrum analysis. Take a spectrum of Ssb signal. So this is the spectrum of Ssb signal S of f. So it is containing only USB only. This is negative USB and this is positive USB. This is USB in positive frequencies. This is USB in negative frequencies. So what is the strength of USB M of 0? That is the maximum strength of the USB. Obtain S of f minus fc. That means shift S of f by fc. So that means you have to shift S of f towards right by amount of fc. So this USB is shifted to fc. Initially it is located at fc, but it's now shifted to fc. So what happened to this one? So this one is shifted towards 0. So this is S of f minus fc. Similarly, you can obtain S of f plus fc. S of f plus fc. So in this case, so you have to shift S of f towards left by amount of fc. So what happens? So this USB shifted to 0. This USB is located at fc. After shifting, it is located at 0, shifted to 0. And what happened to this one? So this one is actually located at fc. After shifting, so it is shifted to 2fc. Now we got two spectrums, S of f minus fc, S of f plus fc. So add two spectrums. After adding two spectrums, okay, this one is added, so this one come down, and similarly, so this one comes down. And what happened? So this triangle is added and this triangle is added. Total we got two triangles. So it is exactly look like spectrum of message signal. Okay. Spectrum of message signal. So S of f minus fc and S of f plus fc added together. Okay. So by adding the two spectrums, so here M of f is obtained here. And what about these? These are higher frequency components. They are removed by LPF. They are removed by LPF. They are removed by LPF. Now look at. So what is happening here? S of f minus fc plus S of f plus fc. So it is nothing but for a transform of S of t into cos of 2 by fct. After passing through LPF, so we obtain some message signal, some maximum limit minus w and plus w. So to obtain the message signal from the S of t, so we have to multiply S of t with cos 2 pi fct and then pass through the LP of, get S of t. So therefore S of t must be applied to the product modulator, and is the carrier signal A dash C cos 2 pi fct is applied to the product modulator. So product modulator multiplies S of t and SSB signal and carrier signal. So output contains product of SSB signal and carrier signal. After passing through the LP of, so it contains the message signal. From the spectral analysis, we have observed that. So take the product of SSB signal S of t and carrier signal, and then pass it through the LP of. Net result is message signal that we have seen through the spectral analysis earlier. Now you can do with the time domain analysis. So carrier signal is multiplied with SSB signal. So SSB signal we know already. So what is the SSB signal? Of ACM of t cos 2 pi fct minus 1 by 4 UAC m cap of t sin 2 pi fct. So you have to multiply this into this with this term and with this term. Now what happens? Of AC dash AC cos square 2 pi fct minus of A dash C AC cos 2 pi sin 2 pi fct cos 2 pi fct m cap of t. So cos square you can write 1 plus cos 2 theta by 2. 1 plus cos 2 theta by 2. So that is 1 plus cos 2 pi 4 pi fct by 2. So here second term you can observe 1 by 4 1 by 2 A dash C AC m cap of t sin 2 pi ct cos 2 pi ct. So cos 2 pi ct. So after expanding 1 by 4 A dash C AC m of 2 plus 1 by 4 A dash C AC cos 2 cos 4 pi fct m of t minus of A dash C AC of sin of 2 sin 2 pi fct cos 2 pi fct. So it looks like 2 sin 2 pi fct cos 2 pi fct. So sin 2 sin theta cos theta you can write it as sin 2 theta. So you can write here sin 4 pi fct. So here second term contains 1 by 4 A dash C AC cos 4 pi fct m of t minus third term 1 by 4 A dash C AC sin 4 pi fct m cap of t. So second term and third term, so indicate higher frequency components, they are removed by the low pass filter. So finally, so output of low pass filter contains only first term only, that is 1 by 4 A dash C AC m of t. So that is a desired one. So what is the need to get a desired message signal without distortion? So it requires carrier frequency and phase must be synchronized. So that is done by the transmitting pilot carrier wire, and second one using stable oscillator. Any error in the frequency or phase, it will introduce distortion in the demodulated signal. So that we will see later. So what is the effect of error in the frequency, and what is the effect of phase error on the demodulated signal, whether it will introduce distortion in the demodulated signal or not. So that we will see in later.